Okay, welcome to Rocking Maths and our version of volumes of prisms and cylinders. We're looking at Texas Standard 8.8b, which says the students will use procedure to determine measurement of three-dimensional figures connecting models of prisms, cylinders, pyramid, spheres, and cones to a formula for these objects, for a formula volume for these objects. We need to first take a look at the volume for prisms, and very, very unique because here we're only concerned with an addition to a formula that we already know, which will be the area of a two-dimensional figure. But here we want to talk about adding depth to this two-dimensional figure by looking at height added onto this formula. We know, or we should know, that volume of a prism deals with the area of the base times the particular height, and we use the formula V is equal to big B times H, and we call it big B because that's a formula within itself, and as you'll see as we go along. So we need to understand what the term volume means, which is really it's a measurement of the amount of space that a particular solid occupies, and it's always measured in cubic units. So 1 cubic unit is the amount of space occupied by a cube that measures 1 unit on each side. So in order to find the volume of a prism, we need to understand that we're looking at again the base, and that particular big base, the base or the area of the base times the particular height. We want to take a look briefly at two different kinds. The first kind we want to look at is a rectangular or a square, but we want to look at a rectangular prism. Rectangular, and that's rectangular. Rectangular prism means that the base, that is the top and the bottom, is shaped as a rectangle, and of course we know that a square is also falls in this dimension as well. So when we look at finding the actual measurement of this, finding the volume of this measurement, we must first take a look at what is the area for this two-dimensional face. And we know that the formula for this area is length times width. So we can say that the formula for the area also constitutes our big B. Okay, so if that's the case, now we just need to make sure that we can add in the other part of our formula, which is base times height. So let's see, can we work this particular volume, this prism, where that carries a length of 12 inches, a width of 8 inches, and a height of 2 inches. So using our formula, volume is equal to big B times height. We can repeat that and say volume, and we said that the base is length times width. So here that's 12 inches times 8 inches, okay, and of course times the height, which is 2 inches. Now as we keep going and multiplying for the big B, we will have 12 times 18, and then I'm sorry, 12 times 8, and that will give us 96, but watch what I do with my units, 96 inches square, because not only am I multiplying 12 times 8, I'm also multiplying inches times inches, and as we do with all variables, that will be inch to the second power, which give us inches squared, times our height, which is 2 inches. Now what this is showing us, and I hope you see that this is going to show us where our inches cubed come from. So now we look at volume is equal to, when we have, and let me break it down here for you, 96 times 2, and that's going to be also inches square times inches to the first power. Okay, so here we'll have 96 times 2, and I'm just trying to be as explicit as I possibly can. That's going to be 192, and then it's going to be times inches to the 2 plus 1. Okay, if that makes sense. And then volume will be 192 inches to the third power, or inches cubed. Okay, so really unique, but again, I want to make sure that I show you where that inch from the third power comes from as well. Now we also said that we can look at another type of prism, which is a triangular prism, and I'm going to go ahead and change the color here so we don't get too mixed up on that. And what the triangular prism does is just simply, again, we're going to use the same little format. It's still base time height, which is what we have here, but when we look at the big B, it's 1/2 the base times the height, and we're talking about the base of the triangle. So what we're trying to do, if you're just familiar with it, this is the formula for the area of a triangle. So that's what we're doing with the big B, finding the area of a triangle and then multiplying the time the height. If you notice, this box is laying down. If we stand it up, it'll stand up on its base, so it'll stand up on the triangle, and that'll show you what the height is. So let's get to work with this. So we got V is equal to, and then we saying 1/2 the base times height, or base times height divided by 2. So I'm looking at a base of 4, and it's showing me that this triangle is 3 meters. So I have 4 meters times 3 meters high, and then of course the whole thing of the prism is 10 meters high. Okay, that makes sense. So now we know that this part is going to be divided by 2. So here we're looking at volume, which is 12 meters square divided by 2, that's a bigger 2, and then that's going to be times 10 meters. Okay, bring it down just a little bit more room. I think we're going to be fine. Here volume is going to equal to 6 meters square times 10 meters, and we'll look at it the same as we did on the other side. 10 times 10 times 6 is 60, and meters to the first power times meters squared gives us meters to the third power, and that will be our answer there. The volume would be 60 meters cubed. So again, this is a general look at how we look at volumes of prisms and cylinders. Of course, we will take a look at several more from a real world situation, but just wanted you to get a bird's eye view of what we're going to encounter in the next few lessons.